Hi, I'm Anthony Del Castillo,
I'm Joe Rice.
And I'm Matt Noyce.
and this is our Lab 10 Fiber Optics Lab video.
Two important concepts that we explored in this lab were optical circulators and optical isolators. An optical circulator is a special fiber optic component that can be used to separate optical signals that travel in opposite directions in an optical fiber. An optical circulator is a 3 or 4 port device designed such that light entering any port exits from the next. Optical circulators are non-reciprocal devices, much like optical isolators. An optical isolator is an optical component which allows the transmission of light in only one direction and is used to prevent unwanted feedback. The most common optical isolator that we've seen in the previous labs is the Faraday rotator.
The concepts in this lab are worth learning about because of their applications to optical communications. Fiber optical cables, for instance, are used to transmit signals, whereas optical isolators only allow signals to travel one direction down the path. Optical circulators also illustrate this phenomena very nicely. Additionally, the concept of fiber splicing is important as it shows how fibers are joined. Long fibers are often needed in optical communications and thus may have to be spliced together.
One significant result that we obtained from this lab was how different splices on a fiber could affect the loss in that fiber. Here we can see a table of the distribution of the loss in milliwatts of each of our 4 different splice attempts. We can see that consistently over our splices, the average loss was around 1.81 milliwatts of power. The second significant result was how alignment of 2 butt-coupled fibers affected the coupling power and efficiency. Here for the change in the X translation, we can see that it only took 2 milli-inches to reach a 3 dB loss in power, while for the translation in the Z direction, it took 50 milli-inches in Z translation to get the same loss in power. So from this we can conclude that the alignment in the X translation direction is more sensitive than the alignment in the Z direction.
This lab compared pretty well with our prior knowledge. Optical fibers worked as we expected them to. It was cool to see the loss distribution of power as placement was changed in free space optical fibers. And yeah, isolators also performed exactly how they have in the past and how we expected them to.
One part of the lab that we really enjoyed was the fiber splicing portion of the lab. Here we have some footage of one of our successful splices, and hot damn, this is cool stuff.
Angle.
No, it's gonna do it.
Here we can see the 2 fibers fusing. Sick.
Look at that.
One part of the lab that we didn't like was the setup for the fiber coupling alignment error section, and we didn't like this because the fiber lengths were long enough that they acted like lever arms and were really sensitive to air fluctuations within the room, and that really drastically changed the power readings that we were getting.